Today we are discussing about in quantum mechanics another concept is physical significance of wave function. Denoted psi. Diagram. Particles x, y, z, value management dv and a psi. This one is x coordinate, y coordinate, z coordinate. This one is origin. Consider a particle having three dimensions along the x, y, z coordinates. The value of psi is associated. It is the motion of the particles at a point x, y, z in space. X, y, z in space. It is related to finding the particle there. Since the wave function psi is a complex quantity, the wave function psi is a complex quantity. It may be conjugate form is psi of x, y, z equal to a plus I b. A plus I b. Here a, b are the real functions. Real functions of variables x, y, z, t, and I equal to root of -1. The wave function psi of conjugate quantity, psi of conjugate quantity, that means psi star x, y, z equal to a minus ib. X, y, z equal to a minus ib. This is equation 1 in equation 2. By multiplying equations 1 and 2, that means P equal to psi star, that equal to psi of x comma y comma z into psi star x comma y comma z, that equal to a plus ib into a minus ib, that equal to a square plus b square. Therefore, P equal to psi star equal to a square plus b square. Therefore, I square equal to 1. Square equal to 1. Here, the product of psi and psi star. The product of psi and psi star is a real and positive. Real and positive if the condition psi not equal to 0. This is known as probability density. Probability density of the motion of the particles of particles with de Broglie wave. De Broglie wave. Suppose when the motion of the particles is confined to the volume element, that means dV, the motion of the particles to be in volume confined to the volume element, that is equal to dV. Then the quantity is P dV. P means psi of x comma y comma z into psi star x comma y comma z dV. Now modulus of psi of x comma y comma z whole square dV. P dV equal to modulus square psi of x comma y comma z. This one is the third equation. This equation represents the motion of the probability of finding the particle in dV surrounding at a point surrounding at points x comma y comma z. Next, when the motion of the particles in one dimension, that is P dx equal to psi of x into psi star x dx, that equal to modulus of psi of x whole square dx. P dx equal to modulus square psi of x dx. This equation is probability of finding a motion of the particles over a small distance of x, over a small distance of x. Once again, I will explain these concepts. First one is, this concept name is physical significance of wave functions. The wave function is denoted by psi. Suppose when you consider particle having a three-dimensional along the x, y, z coordinates. The value of the wave function psi is associated to the motion of the particle at a point x, y, z is in free space in x, y, z coordinates to find the motion of the particles. Since psi is the wave function, that is the psi is the complex quantity. It may be written in the complex form is psi of x, y, z equal to a plus ib. This is the equation 1. In this equation, where a comma b are real functions of variables x, y, z, t and I equal to root of -1. Next, the wave function psi of conjugate quantity, that means psi star of x comma y comma z equal to a minus ib. This one is the equation 2. By multiplying equation 1 and equation 2, that equal denoted the multiplication is p, that equals psi star equal to psi of xyz into psi star xyz. The psi of xyz equal to a plus ib, psi star of xyz equal to a minus b. Therefore, I square equal to 1. Final equation, probability p equal to psi star equal to a square plus b square. The product of psi and psi star is a real and positive. If the condition psi not equal to 0, this is known as probability density of motion of the particle with de Broglie wave. Suppose when the motion of the particle is confined to volume element dv, then the quantity is pdv. P means psi of xyz into psi star of xyz into dv. pdv equal to modulus square psi of xyz dv. This equation represents this probability of finding the motion of the particle surrounding at a points of x, y, z. Next, the motion of the particle in one dimensional, that means p dx equal to psi of x into psi star of x dx. p dx equal to modulus square psi of x dx. This equation represents the motion of the particle in one dimensional over a small distance of x. This equation, right? Equation 4. Finally, this concept is physical significance of wave function.